there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vanjibona, and from this episode we are talking about another object orientation principle, polymorphism. To see how the polymorphism works out, first we have to step back and look at the way that we have normally declare a reference variable and create an object. As we have already covered up this, let's do a quick revise on the 3 steps of object declaration and assignment. In the first step, we declare a reference variable, my dog, and it will tell the JVM to allocate a space for a reference variable. This reference variable is forever of type dog. In other words, a remote control that has buttons to control a dog, but not a cat. In the second step, we create an object and it will tell the JVM to allocate a space for a new dog object on the garbage collectible heap. In the third step, we link the object and the reference. By using the equal sign, we assign the new dog to the reference variable my dog. In other words, program the remote control. Now up to this point, all the examples that we have shown you has the same reference type and the object type. In this example also, both are dogs. But with polymorphism, the object type and the reference type can be different. Something like you see in here. Reference variable type is declared as animal, but the object is created as new dog. That is because dog is an animal. If we extend the dog class from the animal class, we can do something like this. And that is called polymorphism. With polymorphism, the reference type can be a superclass of the actual object type. When you declare a reference variable, any object that passes the is-a test for the declared type of the reference variable can be assigned to that reference. In other words, anything that extends the declared reference variable type can be assigned to the reference variable. This will let you to do things like making polymorphic arrays. You will get a better understanding when we try to do a practical work. Let's go for that. Here we have our main class, which includes the main method, and here is our inheritance tree. The superclass is animal class and it got 2 methods, eat method and the roam method, and these are the subclasses dog, cat and lion. You can see in the class definition, dog extends animal, cat extends animal and lion extends animal. In the dog class, it is overriding the roam method, and in the cat class it is overriding the eat method, and inside the eat method you can see it calls for the superclasses eat method, super.eat, and also the eat method including a custom code segment. And in the lion class there is nothing inside the lion class. Now in the main method we declare an array of type animal, in other words an array that will hold the objects of type animal. The length is 4. Now with these code segments we are putting all the kinds of animals in this array. In the index position 0 we are having the animal itself and a dog and then a cat and then a lion. Now we got a for loop, so we are looping through this array that we have declared. In the for loop we have declared and initialized the variable I with the initial value 0. As I is used as the index of the array, we can say this is a counter variable. Now in the condition part, we are using the keyword length. By using the length keyword for an array, we can obtain the length of an array. That means this will return the value 4. In the third part of the for loop, it is incrementing the variable I by 1. Inside the for loop, it is calling for the methods eat and roam by each object in the animal array. Let's go through this loop. When I is 0, that means 0th index position of the array, it is calling the eat method and the roam method from the animal class. Now when the I is 1, that means index position 1, it is calling the eat and roam method from the dog class. Now in the dog class, the eat method will be this one and the row method is overriding in here. Therefore, this statement will be printed out when the row method is calling. Now, when the I is 2, that means index position 2, the roam and eat method would be from the cat class. Now, in here, the cat class, it is overriding the eat method with using the superclass's eat method. That means both of this statement and this statement will be printed out, and also for the row method this statement will be printed out. Now when the I is 3, that means index position 3, eat and row method would be from the lion class. As lion class is not overriding any method, the superclass methods will be using. That means this statement and this statement would be printed out, and that would be the output of this program. Let's compile and run and find out whether that kind of output can be obtained. So I'm going to type javac main.java. So no compile time errors, therefore we can run this. So here you can see when the index position is 0, it is calling the eating and roaming method from the animal class, and when the index position is 1, that means these two statements, it is calling the eat method from the animal class and roam method from the overridden roam method. When the index position is 2, that means when it is cat, the eat method is calling the superclass's eat method, that means this statement, and it is also output this statement too. So eating and cat is eating are both in there. Now for the roaming method, it is using the animal class's roam method. Now when the index position is 3, that means when it is lion, as lion is not overriding any method, both the animal classes method is using in here, eating and roaming. So our output is correct. Hope you got a good understanding of what is polymorphic arrays. Now let's go for the polymorphic arguments and return types. If we can declare a reference variable of a super type, say animal, and assign a subclass object to it, say dog, think of how that might work when the reference is an argument to a method. Let me explain this with an example. Here I have changed our previous code and inserted a new class called vet. In the vet class, it has a method and it takes a parameter animal. The animal parameter can take any animal type as the argument, and when the vet is done giving the shot, it tells the animal to make a noise, and whatever the animal is, it can make a noise. This is our inheritance tree. The superclass is animal and the subclasses are dog, cat and lion. The animal class have a method called make noise. The dog and cat classes are overriding it, and the lion class doesn't have anything. In the main method we got a vet object, dog object, cat object and a lion object. By using the vet object we are calling the give shot method. And each time we are calling the give shot method, we are passing the arguments dog, cat and lion. And remember, in the give shot method in the vet class, taking the parameter animal. Now how could you do something like that, passing another type argument? Well, actually that is because dog, cat and lion classes are all subclasses of the animal class. Therefore no problem with this kind of a argument passing. Now let's try to compile and run this source code. Javac main.java. Now compile errors. So here we got the output. By passing the dog object for the give shot method as argument, we will call the dog classes make noise. And then by passing the cat object for the give shot method argument, we will get the cat make noise print statement. And then the final give shot method, we are passing the lion object. As lion class doesn't override the make noise method, we will call the animal classes make noise print statement. Hope you got a perfect understanding of what are polymorphic arguments and return types. If you write a code using polymorphic arguments where you declare the method parameter as a superclass type, you can pass in any subclass object at runtime. With polymorphism, you can write code that doesn't have to change when you introduce new subclass types into your program. Remember the web class? If you write that web class using arguments declared as type animal, your code can handle any animal subclass. That means if others want to take advantage of your vet class, all they have to do is make sure their new animal type extend class animal. And also, the vet methods will be still working on, even though the vet class written without any knowledge of the new animal subtypes, the vet will be working on. Now it's time for the frequently asked questions. These questions may be arrived for the people who getting to know the polymorphism concept. So the first question is, are there any practical limits on the levels of subclassing? How deep can you go? Well, actually there is no limit, but it is better to keep the inheritance tree shallow. Now the second question. If we don't have access to the source code of a class, but we want to change the way the method of the class works, could we use subclassing to do that? To extend the bad class and override the method with our own better code? Yep, that's one cool feature of object orientation. And sometimes it saves you from having to rewrite the class from scratch or track down the programmer who hid the source code. Here is another frequently asked question. Can we extend any class? There are three things that can prevent a class from being subclassed. The first one is access controlling. Even though a class can't be marked as private, a class can be non-public. That is when you don't declare the class as public. In other words, a default class. A non-public class, or else this default class, can be subclassed only by classes in the same package as the class. Classes in a different package won't be able to subclass the non-public class. The second thing that stops a class from being subclassed is the keyword modifier final. A final class means that it's the end of the inheritance line. Nobody ever can extend a final class. The third issue is that if a class has something called private constructors, it can't be subclassed. Now this keyword final. Why would you ever want to make a final class? What are the advantages there would be in preventing a class from being subclassed? Well, if you need security of knowing that the methods will always work the way that you wrote them, a final class will give that to you. Imagine the havoc if somebody came along and changed the way your class should behave. So by using the final keyword, we can avoid this kind of situations. Okay, now we made the class as final, but how about making the methods final rather than making the whole class final? Yes, no problem in that. If you want to protect a specific method from being overridden, mark the method with the final modifier and mark the whole class as final if you want to guarantee that none of the methods in the class will ever be overridden. And that's all what we got here in this episode. From this episode, we talked about almost everything that is related to polymorphism and inheritance. And there is another thing that polymorphism related with the something called inheritance. But that is not under our scope. So thank you for watching. From the next lecture, we are talking about overriding and overloading. See you again in next lecture. This video brought to you by edupediaworld.com. Watch more from our website.